In this sequence of videos, we're going to discuss the inverse function. Let's briefly discuss what the inverse function is. Let's suppose we have a function, f. This function has inputs, which we usually call x, and outputs, which we usually call y. The role of the inverse function is to reverse the inputs and outputs. That is, the inputs for the inverse function will be the outputs of the original function. So for example, if I were to tell you that f of 1 is equal to 4, then we can determine the inverse function at the value of 4, and we'll have to introduce the notation of the inverse function. We write f minus 1. The inverse function evaluated at 4 would be equal to 1. And to reiterate, this is true because the inverse function switches the outputs and the inputs. So since at the input of x equals 1, the output is 4 for the function f, if we switch those, we get f inverse of 4 would be equal to 1. As another example, if we knew that f of 2 was equal to 7, then we would know that the inverse of the function f at 7 would be equal to 2. Now that you have a basic idea about what the inverse is, please take note of what the inverse of a function is not. This is a very frequent misunderstanding due to the notation of the inverse function. The inverse of a function is not 1 divided by that function. It's understandable why one would make that error when one first starts learning about inverse functions, because when you have something such as 2 to the minus 1, this is the same thing as 1 over 2. But when we're talking in the context of inverses of functions, it is simply not true. Please keep this thought in mind as you go through the content of this particular topic.